Lesson 2-2 warm-up. Pause to do the warm-up. And here are the answers. Lesson 2-2, linear relations and functions. Objective, identify linear relations and functions and write linear equations in standard form. Let's take a look at a linear relation versus a nonlinear relation. In a linear relation, we are going to see x's and y's being added, subtracted, and the x or y can be multiplied by a variable, by the constant. So we can take y or x and multiply it by some kind of constant here. So these are examples of linear equations. X's and y's added or subtracted, x's and y's being multiplied by some kind of constant. We can have just an x, or we can just have a y. And then here's hopefully a familiar form, y equal to mx plus b, and y equal to mx, and then our b looks like it's 0. These are nonlinear. Whenever you have a square root, the two variables being multiplied, or the variable in the denominator, we say that is nonlinear. Linear equations follow this kind of format of mx plus b, and if you can write it that way, certainly it's going to be a line. Let's take a look at and state whether this is a linear function. And we can see that we can rewrite this as mx plus b by just switching this around. So the answer is yes. Now the variables in the denominator, so that's why this is not linear, and the two variables are being multiplied together, so the answer is no. All right, so is this a linear function? The answer is no. Why? Because the variable is in the denominator. Over here, this looks like mx plus b, and so the answer is yes, this is linear. Pause, you do the problem, and here are the answers. Let's take a look at an example using a linear function. In this function, notice that we're not using y, we're using f of x. This has that mx plus b, where x represents the number of days, and f of x represents the height of the grass. So the question is, how tall is the sample after 3 days? So we're going to find f of 3, putting 3 inside, and we get our height of our grass. Okay, now it asks us, the term 3.25 represents the height of the grass when it is initially measured. In other words, if we were to put a 0 in here at the initial time, the grass starts off at being 3.25 before we watch it grow. So the sample is how many times as tall after 3 days. So we want to take 20.95, divide it by what we started at in the beginning, and we can see it's grown 6.4 times as much. Using this same equation, let's see if we can answer other questions. Now we're being told this is how tall the grass is. We're being given this number, 50.45. And the question is, how many days has it been since it was last cut? So we are looking for x. Now to get x, we're going to solve for x, which means I'm going to subtract 3.25. 47.2 is equal to 5.9x. Now I'm going to divide both sides by 5.9, and the answer is 8 equals x, and 8 stands for 8 days. Now the question is it reasonable that this growth rate can maintain for long periods of time? So the question is, after 15 days, can we really use this equation? After 365 days, a whole year, can we continue to use this equation? And the answer is no. Realistically, grass will only have grow so much, and then it'll reach its peak and it'll not grow anymore. So after 365 days, we can't expect to have unlimited growth. Pause, and you do the problem. Pause, you do the problem. Let's talk about standard form for a line. Standard form looks like this. Ax plus by is equal to c, where x's and y's are on one side, the constant is on the other. Now this is what we were working with before, y equals mx plus b. What we want to do is we just want to take the x and move it to the other side. And when we do that, that'll be negative mx plus y is equal to b. And this is what we call standard form, because the x's and the y's are on one side and the constant is on the other side. Let's go ahead and work with a linear equation and identify a, b, and c. So what we want to do is we want to move the y to the other side. And so now that'll be negative 3/10x minus 8y is equal to negative 15. So we have it in standard form. We can go one step further and get rid of the fraction by multiplying by negative 10. And then our a, b, and c are now integers, which is what we want. We want to be able to have a, b, and c be integers. So let's write each equation in standard form, which means I want to take the x and move it to the other side. So this will be negative 4x plus 2y is equal to 5. And now it's in standard form. I can identify that a is negative 4, b is 2, and c is 5. Right here, what I'm going to do is I'm going to move the 9 to the other side. And so now I'm going to have 3x minus 6y is equal to 9. So my a will be 3, my b is negative 6, and my c is equal to 9. Your turn. And here's the answer. Since 2 points determine a line, one way to graph a line is to find the points at which the graph intersects the x-axis and the y-axis, both axes, and then connect them with a line. So this is a nice way to graph lines right away. Now the x-intercept is where it crosses the x-axis and y is 0, and the y-intercept is where it crosses the y-axis and x is equal to 0. So in this particular case, the x-intercept will be negative 4, 0, and the y-intercept will be 0, 8/3. All right, let's go ahead and see if we can find the x and y intercept. Remember, the x-intercept is when y is equal to 0, and so everywhere you see a y, you write 0, and then you just solve. Now, I want to show you a quick way. When y is equal to 0, right here, when y is equal to 0, this whole thing becomes 0. And a lot of us just do this in their head. And so then x will be equal to, divide both sides by 2, negative 4. If we want to find the y-intercept is when x is equal to 0. So that means this is going to be 0, so this goes to 0. And then a lot of us just do this in our head, and we just divide both sides by negative 3, so y is equal to 8/3. So a lot of us do this in our head without going and showing every single step. Once we graph these 2 points, we graph negative 4, 0, and 0, 8/3. We can draw a line through them, and that will be the graph of our linear equation. Let's go ahead and practice graphing this one. Now I'm going to put it in standard form, which means I'm going to make sure that the 10 goes to the other side. And so I'm going to get this. Now an x-intercept is when y is equal to 0. So that means this is going to go to 0. And then therefore x is equal to 5. I'm going to take the equation again, but this time I'm going to let x equal to 0. When x goes to 0, that means y is equal to 2. Let's go ahead and graph these points and then connect the line, and we have found the graph. Pause, and here's the answer. Pause, and here's the answer. Let's do one last problem. I need for you to take a look at this problem, pause, and see if you can take a look at A, B, and C, and then you may look at the answer. And here's the answer.